Okay, you said 15, young man? All right. Yesterday is, yeah. I emailed you the link. Yeah, it's all good. Um, yeah. So what do you want to do first? Okay. How? But they're on the opposite sides. Yeah, you got to subtract them because they're on opposite sides with equal signs. You have to do the opposite thing. Yeah. Really. Okay. Go. Keep going. Okay. Yep. Was it a good one? Did you go couch or bed? Bed. Did you go like under the covers? Totally went for it. Yeah. Nice. What? Nope. Okay. Um, yeah. These the last ones are review problems. So how do I do? What was 16? Yes, sir. You do. Right. Yep. Oh yeah. Right. Yep. Yeah. Good. Moving on. Oh no, there's no reason to guess and check. Ombre. What do we do first? There you go. And there you go. Okay, you're thinking of number 18 as kind of a guess and check. So 3 times itself, how many times is 81? So 3 times 3 is 9. 3 times 3 times 3 is 27. Huh? Oh, 3 times 3 times 3 is 81. So since it takes 4 of them, the answer is 4. Did you? Okay, that's good. Those ones are kind of rough. You start by adding what? 4x. It happened. Nice. 3x. What? Do you, I'm. Yeah. Sorry, I couldn't hear you. Nathan was getting a little excited there. Why? Why would you do that, Celia? Yeah, that's fine. Yeah. Okay. You good? Okay. There's a couple more. Face mask. Ah, okay. So this is kind of funky because we are combining both of the things from before. So what do we do first? Uh-huh. Okay, 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. There you go. Is the answer to a lot of them 5? Maybe they're just trying to... Hmm. Too bad it's not 5 of them. If the answer to 5 of them is 5, then... Okay, what do we do now? Subtract 3. Talia? Oh, nope, I answered your question, sorry. I couldn't remember. What do I do for this one? You can die from too much of anything. You can die from too much water. So, sure you can die from too much melatonin. Yeah, what we did yesterday's online. Yep. What? Because they were saying, oh, the answer to all of them is 5. So I'm just being annoying. What happens next? It says Alonzo, Maria, and Sierra were floating in inner tubes down a river, enjoying their day. So picture them floating down it's the Wainuchi. The Nooch. Alonzo noticed that sometimes the water level was higher in some places than in others. Maria noticed that there were times they seemed to be moving faster than at other times. Sierra laughed and said, math is everywhere. So, to learn more about the river, Alonzo and Maria collected some data throughout the trip. So here is the time that they were floating, and then underneath that, they wrote down some of the depths of the river they were floating in feet.
How do they know that is that deep?
They took a stick and they stuck it in the water every 10 minutes.
I don't think a stick is 120 feet.
I don't either. This is the time.
Okay.
So the deepest the water was 12 feet. So all they needed was a 12-foot stick. Well, 13 so you can hold on. Okay? All right, use the data collected by Alonzo to interpret the key features of this relationship. So what's going on with the depth of the river? Okay, it seems to be fluctuating. So it's I'm not really sure what they're wanting us to write here. It's going up. Uh-oh, I'm out of ink. There we go. Dylan. Never. It's going up and down. I don't really know what else they want us to say there. It starts out at 4 feet, goes up to 10, and then it goes back down, and then it goes up to 12, and then it goes back down. So it looks like, for us to make like a graph or something, it starts like this and then goes up and then it goes down like that and then it goes up and then it goes like that. Okay? Aha! Okay. So it seems to be going up and down. It seems to be fluctuating. Okay? All right. Maria created a graph by collecting data on a GPS unit that told her the distance she had traveled over a period of time. So I don't know if you guys know this, but they have those apps. Like I have a bike riding app, and it just tells me how far I've gone. So she just had her phone out, and what she wrote down is how far they'd gone in feet and how long it had taken them to go that far. So why did she give her? Yeah, that's interesting because 10,000 feet is like almost 2 miles, huh? Yeah. Wait a minute. So you're telling me that this is in, oh no, that's in minutes. And what is this in minutes too? Yeah, okay. So the units are the same. Maybe that's why. Because the depth of the river, they were measuring that in feet, and so they measured their distance in feet also to keep the units the same. Let's go with that. Next year when somebody asks me that question, I'll just open with that, pretend like I know. All right, using the graph created by Maria, describe the key features such as increasing, decreasing domain range, maximum, minimum, and intercepts of this relationship. Okay, so where is the graph increasing? Yeah, from the very beginning. Does it ever go down? Okay, so and that makes sense, right? Because that's the distance that they're traveling. So what that means is they never go backwards, right? They're going downriver the whole time. So increasing distance the whole way. That is a terrific question. What would, yeah, then if they'd have stopped for lunch, there would be a flat part where the distance wouldn't be changing at all. Okay? Right, exactly. So when we were draining the pool yesterday, when the pool was empty, then there was a flat part at 0. Okay? Yeah, so that's a good point. So you can see that since there is no flat part here, they were going the whole time. Yeah, and they also never went backwards because the graph never went down. Okay? So the distance is increasing the whole way. What's the domain? The domain is the x value. So what's the smallest x value? 0. And what's the highest x value? 120. So that means you, yeah, thank you. That means that you know that they were on the river for a total of 120 minutes or 2 hours. What's the range? Zero to 10,000. We're going by 2,000s, right? So 12,000, 14, 16. Oh, but they stopped right here. So what is that? Okay, 16,000. So that means they went a total of 16,000 feet on the river. Okay. What is the, well, I don't want to do maximum minimum, that and intercepts are dumb. What do you notice about the slope of the graph? It's increasing the whole time. Okay, good. Yeah, that's what I was looking for. Say that again. Okay, so this is pretty steep, and then it slows down, and then it's steep again, and in the beginning it's not as steep. What would the slope of the graph represent? What physical thing is happening when the slope of the graph changes? Not hills because we're on a river. What? The depth of the water is this one over here. This one is just the distance, the speed, right? Because distance divided by time gives you speed, right? So that means these two places, they're going faster. Right, and then these two places, they're going slower. What did you say? Faster in the shallower waters? The river moves faster when it's shallow? Pretty sure? Yeah, I mean, I think when you think about, no, I think when you think about rapids, those are a lot of times in a shallower stretch, and then when you have a deep stretch, it seems like it kind of slows down because there's more water for it to, I don't know if that's always the case, but you think so? Because it is shallow, right? So you can see the ripples, yeah. Yeah, well, I don't know. That's an interesting question. How does it relate to this, though? Here, well, I don't know. We'll just see. Okay, does this make sense? Is this what you're going to do this summer when you're floating the Nietzsche? You're going to make some depth measurements and GPS and... But you floated the river. Okay. All right. Number 3. So I think that Alonzo made the first graph, the other chick made the second graph, and then Sierra is going to put it all together. So Sierra looked at the data collected by her 2 friends and made several of her own observations. Explain why you either agree or disagree with each observation made. So let's get something going here. Riley? The first claim is that the depth of the water increases and decreases throughout the 120 minutes of floating down the river. What do you think? True or false? True. Okay, yeah, it increases to here, and then it increases, and then it decreases. So this seems to be very bad. Okay. All right, part B. Nathan? The next claim is the distance traveled is always increasing. True? Yeah, we kind of talked about that already, that they never turn around and go backwards. Okay, so that is also true. All right, next one is the distance traveled is a function of time. Lindsay? No, sorry, you're wrong. Jaren? The distance traveled is a function of time. So here's the distance time thingy. Is that a function? Why not? Oh, I see what you're saying. Okay, so you're thinking like, right, okay. So the distance traveled is a function of time. And you're saying, tell me why you say no again? Does the distance that they have traveled depend on how long they've been on the river? Or anyone? No? Does the distance that they have traveled Does the distance that they've traveled depend on how long they've been on the river? No? What does the distance they traveled depend on? What's that? Yeah, I don't think they haven't talked about any paddling. I don't think we're doing any paddling. Right, that they have to scoot around or whatever. The distance that they've traveled depends on how fast they were moving. Partly, okay. All right. So, yeah, it's not a river, so that doesn't make any sense. Watch your language. Um, I I understand what you guys are saying. I would have said true on that one, because the farther the more time they've been on the river, the farther they've gone. Those two things are related. But I understand what you guys are saying too, that there are other factors that are affecting that as well. So maybe we could go either way on that one, depending on how we explained it. All right, next one. The distance traveled is greatest during the last 10 minutes of the trip than any other time. Okay, so let's look at the last 10 minutes of the trip. Luis. Yes. You think it might be the same as that one? Here, let me get some of this junk out of the way. The last 10 minutes is this part right here, right? So from here to here, how far did they go? This is, what? They were going about what's that? A little over 1,000. So in the last 10 minutes, they went a little bit greater than 2,000. This is the other candidate right here, right? Where they might have gone farther. So from here to here, did they go farther? No, that's a different 10-minute period that seems like it looks about the same. So yeah, so from 30 to 40 minutes, they also went more than 2,000. So false then. If there's two that are the same, it's not more than, right? Okay, false. 30 to 40 minutes was about the same. Okay. All right, next one. The domain of the distance time graph is all real numbers. McKenna, what you think? You think it's true? Because from 0 to 120, those are all real, bless you, all real numbers. I think the only thing that would make that false is that it does stop, right? They eventually did get off the river. So they're all, the domain is all real numbers, but not all real numbers are the domain. Like if you said 180 minutes, that wouldn't be in the domain, but the numbers that are in the domain are all, yeah, okay. So you're going to go with true on that one? Okay, the y-intercept of the depth of water over time function is 0, 0. Does she? Where does that graph start? What's... Okay, we'll skip it. Okay. Weston? But they're asking particularly about what is the water depth when they started. And the question is, was the water depth 0 when they started? What is the water depth when they started? So, yes, 4. Okay, and so since that's not 0, then that means... So it would be 0, 4, not 0, 0. So that's false. It would be 0, 4. Okay? All right, G. Yo. Yeah, we're done with those. All right, Dylan, the distance traveled increases and decreases over time. No, but in this particular case, not philosophically speaking, in this particular case, here's our distance traveled. Does it both increase and decrease? No, it's increasing the entire time. We talked about that right here. So that is also false. Ooh, here's a good one. All right, next one. It says the depth of the water is never 11 feet. Talia, what do you think? Why do you think that's false? I agree. Why do you think that's false? Okay, we're looking at the... right, at some point it has to be 11 because we know that at some point it was 7 and at some point it was 12 and Dylan's going to hit us with some like way that this could be untrue, like a waterfall or something, but if the water level is 7 feet and then at some time later it's 12 feet, that means at some point in between it had to be 11, okay? And that means that's because this is what type of function? It's not exponential. No, it's not necessarily continuous. Yeah, this is a continuous function, so it goes through all of the points in between. So this is false. It's a continuous function. Okay, next one. The range of the distance time graph is from 0 to 15 million. No, 15,000. Me, okay? Me. I'm that party pooper, all right? That's why I don't have any friends. That's why... No. Matthew? Matthew? Is the range of this from 0 to 15,000? It goes over, so that means no, right? We decided this point right here would be at 10, 12, 14, 16. Yeah, for it to be 15,000, it would have had to stop in the middle there. So that is false. It's from 0 to 16,000. Okay? All right, next one. The domain of the depth of water is from 0 to 120. So if we look at the x values for the depth of the water, Weston. This question right here, just translating it into English is... Okay, this one is basically asking, are the x values of the depth thingy, do they go from 0 to 120?
Yes.
And if you look at the x values from the depth thingy, then they go from 0 to 120. Okay, so it is true. That's true. Okay, the range of the depth of water over time is from 4 to 5. Matthew, is the range of the depth of the water, the Y values, do they go from 4 to 5? Only from 4 to 5? Matthew, hello. What does it go? It starts at 4 and it ends at 5. So it goes past that, yeah. So the range is from the lowest Y value to the highest Y value, not from the beginning to the end. So what would the range of it be? 4 to 12. So that would be a big fat falso. The range is from 4 to 12. Okay, next one. The distance time graph has no maximum value. Luis, distance time graph, does that have a maximum value? Does that have a high point? Yeah. It's, what's that? I mean, kind of. It'd be what? Yeah, if it goes in the ocean and you just float around the ocean until the day you die, but then you would die and then the graph would stop. Yeah. So it does have to have a maximum value. So that would be false. That's exactly why you do that. And the maximum value is 16,000. All right, last one. The depth of the water reached a maximum at 30 minutes. It's another good one. And it's another Talia. She gets all the good ones. Did the depth of the water reach a maximum at 30 minutes? No. Right, because the maximum depth happened at 90 minutes. Do we know that? Why not? Okay, so they might have like measured it incorrectly. Is that what you're going with? Exactly. Yeah, it could have been in between there somewhere. Yeah. Okay. Yeah. Okay. All right. False. So really, that's unknown. That's unknown. Okay. Okay. That's it. It says false. The maximum was 16,000. Okay, so will you guys start working on the homework associated with lesson 2? Okay, where is it increasing and decreasing? So it's increasing from -10 to -7. It's also increasing from, yeah. Uh-huh. And from okay, then decreasing from, okay, and, yep, okay, yeah. Number 2, if it has a minimum or a maximum, does it have a highest point? What is it? I want the Y value for this. Okay, sorry I did the wrong one first. That's maximum is 8. What's the lowest point? Okay. Okay, then the domain is weird because there's those little breaks. So this piece goes from what x values? It starts at -13, right? And then it goes to -7. And then the next piece goes from -6 to +5. And then the last piece goes from, okay. And then the range is the y values. We need range, man. What's the lowest y value? 1. And then in that piece it starts at 1 and it goes up to 4. And then there's another piece that starts at y equals 5 and goes up to 8. Yeah. And if you want to know the description, I don't want to what's the description of the function, I guess it's called a piecewise function. Because it's got 3 different pieces and they're all really smart. Those are called a piecewise function when it's broken up into pieces like that.
That's too much for me.
Right? Okay. Next one. Okay, description of function. What kind of function is this? Nope. Yeah, so what is that called? No, it's continuous. I'll give you a hint. It starts with an x and ends with potential. Right. It's an exponential function. Alright, so the first thing we're supposed to do is say where it's increasing. Never increasing. Where is it decreasing? Yeah, and it looks like it starts at about x equals 0. So I'm going to say that it's decreasing from 0 to infinity. And it's hard to see that it's going down here at the end, but it is slowly going down. All right. Does it have a maximum?
Yeah.
What is it? Sure. Does it have a minimum? Nope. Nope. What is it bottoming out at here? 3. Yeah. And then the number 3 is domain and range. So what's the lowest x value? X value? No. What's the low? There you go. Yep. And how far does it go this way? Infinity. I think because there's an arrow on the end, it goes forever. And then what is the range? What's the lowest y value? 3. Now I'm going to go the other way around. I'm going to go 3 to infinity. I'm just going to go smaller. 1 to bigger 1. Okay? Okay. Can we sneak one more in?
Yeah, there's one more.
One more of these. Is it linear? No? Oh. Yeah. Okay. So that's a piecewise function again. That is definitely wonky. This one is increasing from, right, but when the x values, where does it start going up? So what's the x value right here? You want to just call that negative 10? Okay. So it's increasing from negative 10 to when does it stop going up? Negative 2. Okay. And then it is decreasing from 5 to, oh, we're looking at the x's. 10, we'll just ignore that little piece on the end there. Here, hang on. You guys never saw that. Then this one also has a place where it's constant. Where is it neither decreasing nor, you say? No. Negative 2 to positive 5. Good. What's the maximum? Right. 2. And the minimum is, we're looking at y values for, yeah, if I didn't erase this little piece, it would have been negative 6, right? So we'll just call that good. All right, and then the domain, the smallest x value is, and the greatest x value is, and for the range, the lowest y value is, and the biggest y value is dose. Okay, awesome. So we will finish up. This looks like there's a couple more. Oh, yep, we're going to need to go through those a little bit together. So we'll mess around with that on Monday.